next presentation is Auction Information Enhanced Framework for CTR Prediction in Online Advertising. And the speaker is Yang.
Hello everyone, I'm Yang from Huawei Noise Arc Lab. Today I'm presenting Auction Information Enhanced Framework for CTR Prediction in Online Advertising. So first let me introduce the background. So the online advertising system based on real-time bidding has achieved great commercial success. And its recommendations are unique compared to general relevance recommendations. So firstly, from the perspective of optimization goals, maximize eCPM versus maximize clicks, dwell time, or user experience. So secondly, from the perspective of ranking rules, its recommendation involves auction mechanism, which makes the system more complex. So from the flowchart below, we can see that before an advertisement is displayed, it will go through the process of model prediction to auction, and the information in the bidding and auction stage is posterior for the CTR or CVR prediction. However, existing CTR prediction models do not fully exploit the signals from posterior stage. And from the formula of eCPM, we can see that the level of eCPM determines whether the aid will be exposed or not. But offline evaluations use like AUC log loss, which can only optimize online CTR, but not revenue or eCPM. Then we have some key observations. Firstly, CTR market price are somewhat positive related according to our industrial experience. And secondly, market price distribution varies greatly under 4 industries in our industrial dataset. And then we discovered auction bias. So when the advertisers bid high, it will lead to some bias in the training sample data. So this is our framework overview. The black part is the basic skeleton of click-through rate estimation, which utilize exposure click-through rate data as well as user, item, and contextual features to model the relevance of users and items. And the blue and the red parts in the figure are our new framework to utilize posterior information from the bidding and auction stage, which corresponds to the utilization. So therefore, our core innovation is to enhance the click-through rate estimation modeling for the first time by utilizing a posterior information in the bidding and auction stage. So for the adaptive market price auxiliary module, we construct an auxiliary task of model of market price regression task to enhance the model's learning of beneficial signals. And we also use dynamic weight generation to perceive market price environment. So for the bid calibration module, we adjust the weights of positive samples according to the bid value to mitigate auction bias. And we also have customized reweighting plans for scenarios with large differences in bid distribution. So our overall performance on a benchmark dataset shows that we have gained significant improvement both on ranking metrics or on revenue metrics. And AIE is also a model-agnostic framework and can be applied to any SOTA models. As for the industrial performance, we achieved form volume in multiple large scenarios, including Huawei ads, Huawei app market, and the RPM and eCPM shows significant improvement in online A/B test and the confidence report. So the main 2 takeaways, the first one, we identified the auction signals utilization problem and auction bias for CTR prediction in online advertising. And secondly, we propose AIE to take advantage of the posterior signals from the bidding and auction phase to enhance the performance of CTR prediction model. Thank you for your listening. Please feel free to connect to me at the poster sessions if you have any questions.
Thank you so